Jerry Sanders graduated with an electrical engineering degree in 1958 and was recruited to Fairchild Semiconductor in 1961. He was a star performer at Fairchild, becoming worldwide sales manager at age 31. Later, Les Hogan was brought in to head Fairchild and ended up firing the brash Sanders. Sanders, along with other ex-Fairchild people, formed AMD, where he was chairman and CEO from 1969 to 2002.
I grew up on the south side of Chicago. I was born to a 17-year-old mother and a 21-year-old father who were madly in love. Unfortunately, being madly in love maybe isn't enough to make a marriage work, so when I was quite young, 3 or 4, they separated. And my first memories were when I was about 5 years old, going into my grandparents' house, having been dropped off by a streetcar at far too young an age, had been dropped off. In today's society, you'd never do that to a child. Maybe you shouldn't have done it then. But I ran into my grandparents' house, and they weren't there. And there were some workmen. I didn't realize at the time they were workmen. I was only 5. In the kitchen, and they said, well, your grandparents don't live here anymore. And I was absolutely terrified. My mother had dropped me off, and I had nowhere to go, and my grandparents lived there. I was really terrified. And it turns out that these guys were just having a little joke on me, not knowing where I'd come from. They thought I was probably just coming in from next door. My grandparents were down in the basement where they'd set up temporary housekeeping in a kitchen while a new GE kitchen was installed. And so we got a new GE refrigerator, but I was terrified. So that doesn't mean that I associate GE with being terrified, but it's my first memory as a child. I had an interesting childhood, being raised by my paternal grandparents, and my grandfather was the first Sanders in generations, the only Sanders until me, that ever had a college degree. And he had a degree from the Armour Institute, which is now Illinois Institute of Technology, in electrical engineering. And he was a graduate in 1906. In 1906, they didn't even have AC current. They only studied DC current. So that was kind of an interesting background. As I went through grade school and high school, my grandfather always told me I would never amount to a hill of anything. He used a more descriptive expletive, that I was a shanty Irishman just like my mother. Well, obviously, that had the effect on me of wanting to prove him wrong. So I did quite well in school. I was blessed with a pretty high natural intelligence, I guess. And I graduated as the valedictorian of my high school. And then I had to make a decision as to what to do with my life. You talk about dreams as a child. My dreams as a child were just to enjoy life. I didn't have any aspirations as a high school student to be a ham radio operator or anything that so many people in high tech did. I never even thought about it. I just wanted to have a happy life. But I knew in order to have a happy life, you had to make a living. My grandfather drove that into me, that you have to make a living, so you should be an engineer. Because if you're an engineer, you can always get a job. So I thought, okay, I guess I'll be an engineer. So I applied for a number of scholarships, and surprisingly, on a competitive basis, I won a scholarship to the university of my choice. And because I wanted to own my own car, and I'd never had a car through high school, which I considered a tremendous setback, even in the early 50s, I was more interested in making sure I could have a car than going to a university. But God smiled on me, and I went to the University of Illinois. And the University of Illinois has turned out to be a phenomenal school for engineering, electrical engineering in particular. And currently, as I tape this interview, I'm very proud of the fact that my company has endowed a chair in it's the AMD Jerry Sanders Chair in Electrical and Computer Engineering at the University of Illinois. I have to tell you, back then I never thought anything like that would ever happen. But I went to the University of Illinois, and I started in as a chemical engineering student. Why chemical engineering? Because chemical engineering, according to what I learned from my placement counselor, paid more money than any other kind of engineering. And as I said, I was just interested in having a good life, and I figured out early that being poor was not good. Turns out I'm the oldest of 12 children, and by definition, that makes you maybe rich in spirit, but maybe not so rich in financial terms. So I started out as a chemical engineer, and to my chagrin, I discovered that chemical engineering was in the School of Liberal Arts and Sciences. So I really wasn't involved with a group of people that really I thought of as engineers. They were all liberal arts people. So through a set of circumstances, which are well documented, I returned to the University of Illinois and transferred into electrical engineering. And I will be eternally thankful to God that I transferred into electrical engineering. Turns out my grandfather was an electrical engineer. I don't know whether that was the influence or not, but it seemed like an appropriate thing to do. So I was kind of interested in that. So when I graduated from the University of Illinois as an electrical engineer, my first desire was to leave the Chicago area where you didn't have a transparent society. In Chicago, as soon as I told people I went to Lindblom High School, Lindblom Technical High School, I might add, that immediately classified me as working class, and I felt like I was never really accepted. And so I thought, this isn't good. Whereas when I'd been in California briefly one summer, I realized that in California, anything east of the Rockies was, foreign territory, and nobody knew anything about that. So I thought, well, I'm going to go to California where I can be judged on my merit and where I can go for fame and fortune. So I moved to California in 1958 upon graduation, and I went to work for Douglas Aircraft Company. And I was amazed. Douglas Aircraft Company was a wonderful place, 3300 Ocean Park Boulevard. I selected the job because it was the closest occupational offer I had to the beach. So far I don't sound like a very serious guy, and I guess I really wasn't. I was 21 years old, and Southern California looked good to me, and I wanted to live near the beach, and I went to work for Douglas Aircraft Company. And amazingly, I was put in charge of a project. I was very, very young, but I was put in charge of a project which was called developing the pitch trim compensator for the DC-8. And actually, the guy who was really in charge of the project was just wrapping it up and leaving to go to Lytton. But I finished it off, and they decided that, okay, I'd done a reasonable job, so they put me in charge of developing, the air conditioning control system for the DC-8. And a company named Colorado Research. Colorado Research had developed one using magnetic amplifiers. Well, I had never worked with magnetic amplifiers, didn't know anything about them, but I quickly got involved, and what I discovered was that this system did not work at all because magnetic amplifiers were very sensitive to voltage transients and spikes. And of course, on a 28-volt nominal power supply in an aircraft, there's plenty of spikes, so that system just did not work. So I was given the task of redesigning this thing, which I did, and I began to work with power transistors and to build a power supply, a regulated power supply, so that we wouldn't be able to screen out all this transient activity. So I contacted Motorola. Motorola Semiconductor was manufacturing power transistors and Zener diodes. And a Zener diode is and was a diode which has a breakdown at a certain voltage, so anything beyond that was damped out and absorbed by the power transistor, and so you had a regulated power supply. Simply put, I was designing a regulated power supply around Motorola's components. So I thought I'd better find some more out about it, so I contacted Motorola, and they sent over a sales engineer. I'll never forget that. He came over, he had beautiful clothing on, he was well-groomed, he didn't know a damn thing about his product line, but he had offered to take me to lunch. We went out to lunch, he drove in a new car, took me to a nice lunch, a better lunch than I certainly could afford as an engineer at Douglas Aircraft Company, and I decided then and there that I had been in the wrong end of engineering. So I applied for a job shortly thereafter at Motorola as a sales engineer, looking forward to the day that I could have a nice car, good clothes, and more money. Well, it turns out that Motorola thought I was a little young, so they hired me on as an applications engineer. And so I worked at Motorola helping other uninformed Motorola sales engineers with what they should have known about their product and help customers use it. So I was quite successful. They moved me quickly into a sales position, and I was given all the rats and dogs of southern Wisconsin, southern Michigan, northern Indiana, and the outskirts of Chicago and northern Illinois, and all the way down to Sangamo Electric in Springfield. And I was quite successful. I was so successful that a company named Fairchild, which I hardly knew anything about, whereas Motorola was a household name in Chicago, I mean, from the days of car radios, contacted me to interview me. They really thought that I would be a great candidate, and they'd like to have me join their company, or at least talk about it. Well, I had no interest in leaving Motorola for a company named Fairchild in Northern California, but I agreed to an interview on the proviso that it could be over a weekend. And my plan, quite simply, was to spend a weekend in California after a brief interview. Well, sometimes reality mugs you. I got out there, and I was frankly blown away by the caliber of the people. Just some incredibly great people. Sales manager was a guy named Don Rogers. Marketing manager was a guy named Tom Bay. These guys were super smart guys. And they introduced me to another feisty little guy who was running a diode operation called John Reddy, who just couldn't tell me enough about how great this company was. And he didn't have to tell me. I was a smart guy. I figured it out. And then I met Bob Noyce, and my world changed. This was the smartest man I'd ever met in my life. He was congenial. He was engaging. And he was just so smart. And we talked about the things they were doing. And I thought to myself, gosh, I just really have to go to work for this company. So that was the end of my playing around in California for the weekend. Instead, I went into my mode of how do I get a job with these guys where I wanted to be. So what they really wanted me to do was be a sales engineer in the Chicago area, basically calling on the same customers where I'd been so effective for their competitor. And they were quite blown away when I said, well, I'll accept a job, but it's got to be in Southern California. And again, I said, this is the place I want to live, and didn't think a lot more about it. But once I got to, anyway, I got the job. I left Motorola. This was in early '61. And my life has just been incredibly great since then. From '61 through '68, I was just thrilled with what was going on in our industry. We were changing the world. Fairchild had invented the silicon planar transistor. They'd invented the monolithic integrated circuit. Bob Noyce was there for any bright young employee to talk to. The rest of the team was motivated highly to be #1 in the industry. And it was just a wonderful period of time as we were inventing new things, opening new markets. I remember there was a guy named Newton Minow who was at the time the head of the FCC. And he mandated that all TV sets had to have UHF. Well, this was a big deal back in those days, in the '60s. Up to there was only a few channels, 1 through 13, and half of those were just static. But all of a sudden, you had to have UHF. So every TV had to have a UHF tuner. Well, to have a UHF tuner, you need a very high-frequency oscillator. Well, Fairchild had a transistor, the 1211. How's that? The 1211, the 2N 1211. And it was a dynamite transistor. And so from that technology, we went out. We were going to go sell these things against an RCA New Vista. RCA New Vista was a solid-state device, sort of, but it still had a cathode, and so it had a lifetime as opposed to or a limited lifetime as opposed to a transistor, which in theory had infinite lifetime. So I went out there, and the only problem was that this device that we were selling, and I said it was the 2N 1211, that's a mistake. It was the 2N 918. 1211 was the internal technology number. So the 2N 918 sold for $150. Well, since they were looking for a product for about $1 for this device, that was kind of a setback for us. But I had this great conversation with Bob Noyce and Tom Bay at Bob Noyce's house. And of course, by this time, Bob was already a wealthy and successful fellow and a beautiful home. And we met on a weekend and offered me a beer, and I never drank beer. Didn't want to drink, didn't want to cloud my mind. And we started talking about this, and I said, I think we can sell this product, but they can only afford to spend less than $2, and they have to see a way to get down below $1. So Bob proceeded to tell me about what they were doing about shrinking the technology, and of course, we've learned since then that that's what's the magic of semiconductors. You just keep building smaller and smaller feature sizes, driving the cost down. And he said, let's just do it. We're going to open a plant in Hong Kong, and we're going to put these things in plastic, and they'll be cheap, and we can just do it. Well, I was blown away, and I went out there, and in my role as, my title was a great title at the time, Director of Entertainment Sales. Sounded like I was selling booking agents or something, but I was actually calling on consumer customers, TV, radio, stereo. as Fairchild was moving from being in the primarily in the military electronics supply chain to consumer and industrial. So is I guess the point I'd like to make with that was it just showed that there was nothing we couldn't do. You know, later on, you know, Thomas Wolfe wrote about masters of the universe, but he didn't have it right. The masters of the universe weren't the guys who were selling stocks and bonds on Wall Street. We were the masters of the universe. We were changing the world. Semiconductor technology was going to let you do things you could never do before and make them available everywhere. So it wasn't very long, as far as today, I mean, nobody even thinks anything about, you know, UHF channels. Now we've got 600 cable channels or satellite channels. But it all started, you know, with an innovative company, Fairchild Semiconductor, with new technology and a marketing drive to change the world. And it was a wonderful place to work, but it had a character flaw. And the character flaw was called Syosset, Long Island. And that's where Fairchild Cameron Instrument was headquartered, and they were the owner of Fairchild Semiconductor. And all the cash flow and all the money that was being made was flowing into their pockets and being dissipated on not such great other activities. Meanwhile, the contributors at Fairchild weren't making very much money particularly, but worse than that, as I got to the end of my time there, the company was being starved for capital investment. And so we couldn't even afford to buy the testers to ensure that we were meeting the specifications. I remember losing business at RCA, of all places, because we were supplying them a current mode logic device we developed, an integrated circuit, a microchip. We couldn't guarantee the quality because we didn't have enough testers to test all the parts. And it was grim. And I thought this was a tragic situation for a company. And I'd remind you that at the time, Texas Instruments was already a giant company when Fairchild got started. And Fairchild got started in '57, as I recall. '58, Bob Noyce invented the integrated circuit, the monolithic integrated circuit. I joined in '61, but by '67 and '68, we were in a serious retreat because, as I say, having won the Minuteman program away from TI with our new technology and our innovation, we'd lost the second go-around to a TI approach, which was the wrong approach, but because we didn't really have the support of corporate back in Syosset, we didn't have the capital being invested to, not to mention the reward to the innovators. So it was a sad time, and Fairchild began to decline, and people started to leave. And it was about that time, of course, that Bob Noyce and Gordon Moore left to found Intel. That was in 1968. At the time, I was still the worldwide marketing director. By that time, I'd been elevated to worldwide marketing director. Still, I was very young and thought the world we could still change the world. Dick Hodgson, who was the president at the time, you know, was a guy I had great admiration for. I was given a bunch of stock options and told that, you know, the world was going to be great. And then, when the world wasn't so great and Fairchild had to cut back, they decided they needed some new management, and we were shocked. They brought in Bob Noyce left, as I said. Charlie Spork, who had been general manager of the business, left to form National. Charlie hired me, or he thinks he hired me. He made me an offer to be his vice president of marketing worldwide, and I said I couldn't do that without telling the people at Fairchild first. And they persuaded me that I would someday be the president of Fairchild, that there was no limit to where I could go. They laid some more stock options on me, and I made the mistake of staying. Turns out it was the right thing to do as life worked out, but I didn't know it at the time. Anyway, Charlie Spork basically said I'd made a terrible mistake, and he found out that the reason I decided to stay was that I had misspoken up until now. I wasn't yet the worldwide marketing director. I was a sales manager, and I said I wanted to be the worldwide director. If I would have joined Charlie, I would have been, but I said I wasn't going to stay on and not be. Well, there was a problem because there was already a worldwide marketing director at Fairchild named Don Valentine, who was a good friend, but I said, you know, Don's there, and I'm behind Don, and I don't want to wait. And Tom Bay said, well, how much time will you give me? And in my brash youth, I said, till Friday. And I think this was on a Monday. And on Friday, Don was terminated, and I was made worldwide marketing director. I was shocked. So there I was at 30 years old, 31 years old, and wow, just had the world was my oyster. But as it turns out, Fairchild had to change managements. Charlie Spork left, Tom Bay was promoted. It didn't work out. They brought in a whole team of guys. Lester Hogan, Hogan's Heroes. Very interesting time. C. Lester Hogan's a brilliant guy, and he'd made Motorola quite a success by automating the production of transistors. But of course, transistors were old news. But that's what made Motorola a success. So he came in, and instead of, I think, taking the advantage of the wonderful innovations and technology that was in place at Fairchild, instead he seemed to want to make them over in Motorola's image. And as I said, I was a brash young man, and I couldn't help but tell him why I thought a lot of things he was doing was wrong. But I guess I should take the time to tell one story that cost me my job. We went to visit Digital Equipment Corporation. In those days, it was called DEC. Now it's just called Digital. Now it's gone. It's part of Compaq, which is now gone, part of HP. But the founder of Digital had a meeting set up with Les Hogan, and we went to meet with him. And when we got there, I had properly briefed Les Hogan on what we should say about our proprietary family of digital building blocks, which were TTL building blocks called MSI, medium scale integration, the 9300. Ken Olson, who was the founder of Digital Equipment, was quite a good engineer, and I thought that he would be very responsive and receptive to our pitch on why these were a superior way to assemble a computer and why they were built with a system in mind as opposed to just being random collections of gates. Well, we talked, and Les said to Ken, so what do you want us to do? So Ken said, well, I got a problem. Texas Instruments has their Series 54, and there's a lot of sources of that, and you're a sole source on the Series 9300. Sure would make my life easier if you just agree to build Series 5474. And to my amazement, Les Hogan said, if that's what you want, that's what we're going to do. Well, what did that mean? It meant that all of our proprietary development, all of our invention, all of our innovation, all of our competitive advantage was down the tubes, and all we had now was the opportunity to be an alternate source to TI, who was already a giant manufacturer. So afterwards, after the meeting, we were outside, and I was just really so upset. I'd worked so hard. My people had worked so hard. All the engineering people had worked so hard to win that design. And all we had to do was say, Series 74 is not competitive with our solution. I'm sorry, but this is the way to go. And I know he would have gone. I mean, you could tell he was just shocked that we agreed. So Les Hogan said, what do you think? And I said, I think you just wrecked the company. Wrong thing to say to the president of a public company, especially when he has just recently taken over. So I think that's what sort of signed my death warrant with Fairchild. But just to close that story out and move on to AMD, which is the pride of my life, short of my daughters, of course. One day, I decided that, which is amazing in retrospect, that I was the best candidate to run the semiconductor operation. As I'd mentioned earlier, Fairchild Cameron Instrument, of which Les Hogan was the president, was the parent company, but he was also acting as vice president and general manager of Fairchild Semiconductor, which was really the heart and soul of the business. But at some point in time, it was pretty clear he was going to name somebody to be president of Fairchild Semiconductor. At least I thought he was. So I said I'd throw my hat in the ring. So I remember Les saying to me, well, Jerry, of course you'll be considered. You're one of the smartest guys I know. And he said, but let me ask you this. What if you aren't named? What if you aren't the guy selected to be the president? Now, I know now that the only thing to say was, Les, whatever you want, I know is whatever you want to do. I'm sure that's the right decision, and I'll support it 100%. But you know, when you're 31, 32 years old, you say, I said, you know, Les, I can't guarantee my behavior. Oh, wow. So not guarantee my behavior was perceived by Lester as a threat. So he hired a guy from TI to replace me, and bingo, I was out. So there I was, you know, a couple of kids, you know, and no job, terrifying. Enough severance pay, thanks to Les's generosity, or maybe I say guilt money, to figure out what to do. And to my amazement, several groups of people approached me to start a semiconductor company. Maybe I ought to take a break there.
Okay.
So,
Need a cough drop?
well, I'm never a guy that likes to look back. So looking back, you know, 3 decades is tough. Looking back 4 decades is even tougher. But I guess I'll really never forget the origin of AMD and how I started that, or how I was part of the starting of that, because it was really an amazing kind of story as I look back on it. I had no idea what I was going to do after having lost my job. I knew that I only had a few months of pay, and then I was going to have to do something because of the circumstances under which I left. Considered to be a brash iconoclast and accused of not having the customer's interest at heart, even accused of wearing a pink suit into IBM, a story which has followed me for 4 decades, totally bogus. I never owned a pink suit. It was just a bizarre story. But in any event, I thought, wow, my life is really over. This is really a terrible place to be. But, as I said in my amazement, a few people approached me. First, a young man named Jack Gifford, who I'd worked with, you know, at Fairchild, who had an idea to start a company to make linear integrated circuits. And that was interesting to me, but frankly, linear integrated circuits, in my view, were a niche opportunity. And although the analog world will always be with us, because that's what the real world is, I just didn't see that as an exciting thing, whereas I was more interested in the digital world, where you could build more and more complex things. And you take advantage of the ever-shrinking transistor sizes, which has been the driving force behind the semiconductor industry for decades. So I was quite pleased when a young man, well, I guess we were all young men at the time, named John Carey, who had run digital integrated circuits at Fairchild and also gotten fired, being, again, an outspoken guy and didn't fit the mold of the Motorola team that had come over from Phoenix, came up to me and suggested that we start a digital integrated circuit company. Well, it turns out when I looked at John's skill sets and I looked at the skill sets of Jack and his team, I thought they were complementary, but nobody had ever started a company to build both digital and analog circuits at the same time, since the processes are incompatible and not going to be an easy thing to do. But I saw it as a bigger playing field. And frankly, I guess there was a certain perverse joy in thinking, if we built digital circuits, I'd build those 9300 MSI circuits, which Les had eschewed and had gone instead just to be an alternate source. I think there's a certain poetic justice. I was going to be an alternate source to a family of products which he had basically abandoned in favor of being an alternate source to some TI products. So I got John and another young man named Sven Simonson together, who was a design guy, and I said, okay, now John can build them and Sven can design them and I can sell them, so there's the digital circuits. Jack was a marketing guy for linear, and he had a couple of good design people and product people, Larry Stenger and Jim Giles and Frank Boddy, and so all of a sudden there we were. We had 7 guys, and then I brought in Ed Turney, who was a longtime friend, to be the sales guy, and that was the first of the problems. Because Jack Gifford said, we don't need a sales guy, you know, you're a sales guy. And I said, no, I'm going to be the president. I'm going to be the president, I can't be the sales guy. And I knew I was going to be on a steep learning curve because I didn't know how to be president. But turns out they didn't really want me to be president anyway. All they wanted me to do was raise the money. They thought I could raise the money. And Jack, I learned after agreeing to try to do this, had already failed for a year and a half to raise any money. He couldn't find any money anywhere. John Carey hadn't tried, and Sven Simonson, the other guy on the digital side, he wouldn't even know how to go about it. He was an engineer's engineer and brilliant at that, but not a money raiser. So I took on the task of raising the money to start AMD. And I wrote the business plan and developed the program to go out to raise money. Bob Noyce often tells a story that it took him 5 minutes to raise $5 million. As I like to say, it took me 5 million minutes to raise $5. I went around, trying to talk to people like Arthur Rock, who had been, an influential venture capitalist at the time. I talked to everybody, and I mean, it went something like this. Number one, we never bought back a company run by a marketing guy. Number two, it's too late to go in the semiconductor business. And number three, all of your people are mediocre. So I thought to myself, wow, this is a really challenging thing. But never say die, because, I guess in some ways I am a sales guy, and, they say that different personalities form different tribes. I'm from the sales tribe, and sales tribe thinks there's nothing you can't accomplish if you put enough energy into it. That's the way I've always lived and felt, and that's what I did then. So I went out and I raised $1,505,000 to close on a $1.5 million closing number that we needed, and AMD was born. Shortly after we were born, Jack Gifford began his campaign to undermine me, to get the guys to throw me out, since now they had successfully gotten the money they needed to do what they wanted to do, and Jack really wanted to be the president. But it turns out nobody wanted Jack to be president except Jack, and so maybe at first they thought, well, Jerry at least deserves a chance. He raised the money. And we began to develop products, and we did a phenomenal job in a very, very bad market, because this was, 1969. May 1st, the company was formed. We raised the money by the fall of '69. But by 1970, the industry was in a terrible downturn, and companies were going away, and we actually were going to need some more money. And I remember this meeting very well, because we used to have these founders meetings. And one night, we said, hey, we got to raise some more money. And I said, you know what? If we raise more money, we have to give up 1/3 of our stock, because the deal we had made was we each got a certain amount of stock, but there was a 50% kicker if we could take the company public without raising any more money, unless the investors waived that. And so everybody said, well, we don't really have a choice. We don't get more money in here, we're not going to be able to be successful. Market's terrible. So we need to do this. You need to go out and raise more money, and we'll give up our stock. So we had a vote, and remember Jack saying, well, Jerry, it looks like you lose. It's 7-1 against you. And I said, no, Jack, I don't lose. It's 1-0, because you guys don't get a vote. We are not going to give up 1/3 of our stock. I will find a way to not do that. So I came up with the idea, we're going to have to raise some more money, but I figured if we gave the investors something new, we'd be able to do it. So I said we're going to expand in MOS. Now you think about this. This was a tiny little company with an analog capability, a digital capability, and now we're going to get an MOS capability? Wow. But MOS, of course, was the coming thing. Of course, we didn't know anything about MOS, but again, I figured I could get some people together. So we raised another $500,000. We didn't give up our stock. And within a few short years, September of 1972, 2.5 years after founding the company, with limited resources, we went public as a profitable company with growing sales. And AMD's origins were just really, it was tough slog, because we started out just being a replicant, if you will, a second source to existing products. People called us copyists. People said we had the least chance of survival of any company. People said we didn't bring anything to the party. And it was really amazing, because some 33 companies were formed in 1967, 1967, 68, 69. Only 2 of them are still here as independent companies, AMD and Intel. And it wasn't that I didn't want to be an innovative guy inventing new and exciting stuff. It's we didn't have enough money to do that. And I saw the market opportunity to actually get to market faster by offering something the customers wanted, which was an alternate source at least as good a price, and maybe a better price, so that they wouldn't be dependent upon one source of supply. And the interesting thing about it, which I found extremely amusing, was that all of our competitors who were denigrating us were all making second source devices, but they all used cross-reference charts. So if there was a Fairchild MU-A741 operational amplifier, Raytheon had some RN6571, which was cross-referenced. Well, that was very tough for the customers to figure out. TI had Series 7400. If somebody else came out with the product, they called it the something else, the Sprague 5839 or something, and that was cross-referenced. So I said, you know what we're going to do? If there's a Fairchild part that's called a MU-A741, the AMD plug-in replacement is going to be the AM741. If there's a National Semiconductor part called the LM101A, there's going to be an AMD plug-in replacement part. It's going to be called the AM101A. If there's a Motorola part called the MC1488, then the replacement part from AMD is going to be the AM1488. Well, nobody ever done this. It seems so obvious. And we got sued by everybody. Everybody came after us. You can't use our number. I said, we're not using your number. We're just using a generic numeric with an AM in front of it. Everybody knows that AM stands for AMD, so they can know the difference between an AMD product and a Fairchild product. And we prevailed. And we became phenomenally successful. And so we grew rapidly to the time frame of 1975, and we had just become a $50 million company, $100 million company. I wanted to be a $1 billion company, a $10 billion company. But at the time, those seemed like far in the future. But I think the interesting thing is we always wanted to innovate. And we said from the beginning there's only three ways to win: out-invest, out-produce, or out-innovate. Well, we couldn't out-invest or out-produce these bigger companies, so we had to out-innovate them. The other thing we said was, or I said was, people first, and products and profits will follow. And I said, we build a great team of people, reward those people, let them know what they think is important, and they're going to come up with great products. We're going to market them properly, and we're going to make money. And it's really amazing because everybody pays lip service to that people count. They're the most important resource. But AMD was the first company to give every employee shares of its stock. We were the first company to go to cash profit sharing. We were the first companies to put in programs where if we made certain goals, tremendous incentives were rewards to people. And we even gave away a house called the American Dream Program and gave one of our operators a house. She won it in a drawing. It was just a phenomenal time. And in 1975, as I say, we introduced our first proprietary products. We invented bit slice microprocessor, the 2901, which became the building block for all of Digital's computers and Data General's computers. And interestingly enough, was later replicated in an integrated form by my good friend and colleague, Wilf Corrigan at LSI Logic, incorporated all those building blocks into his gate arrays and custom circuits, ASICs. But the interesting thing was that we said then, and we say now, and it's pretty hard to have in an industry as dynamic as ours, the same mantra for 33 years. But that mantra was building blocks of ever-increasing complexity to improve the performance, reduce the cost, and shorten the time to market for equipment makers for computation and communications. And we've been doing that at AMD for 33 years. Today, AMD is in rarefied air. I mean, we earned $1 billion net after taxes in 2000, and nearly $5 billion in sales. For the last 5 years, we've been in the top 25 companies in the world in US patents granted. Last year we were number 13. We continue to move up. We even have more patents granted last year than Hewlett-Packard or Intel, who are considered to be wildly innovative companies. And through it all, I think we've been true to our value to the people, which is people first, and products and profits will follow.
Well, what I noticed being a design engineer at Fairchild was that we were not appreciated. The process guys were, but they didn't even get patents on things like the 9310 and those circuits. which TI took and gave them 7400 numbers
Yeah.
and made them famous. And so what I noticed sitting over at Fairchild looking at AMD was that design engineers were well regarded and taken care of here.
Yeah, it seems fairly obvious now, but it's all about content. You know, blank film may be difficult to produce and it takes some sophisticated processing, but what really makes it valuable is what you put on the film. What's the movie you make? I've always said at AMD, we've got that the center of our business is this big green ball. Green is our corporate color. It's supposed to be for making money and also greening the earth, but it's also about, it's the center is process technology. But again, it's just the tool. Without the actual content, what do you use that process technology to do? What good is it? Last night I was talking to a group of engineers and they were asking me how we feel about Moore's Law. And I said, what do you mean how we feel about Moore's Law? First of all, Moore's Law is an observation. It's not a law. And it talks about how, and by the way, it's been corrupted so many times. Now people say, well, it means you double computing power every 18 months. It started out that you doubled the number of transistors you could put on a chip every 18 months. And we've been able to do that as an industry, and AMD as a company, for 3 decades. And we'll continue to do that at least through this decade. And I don't see why I couldn't go on in future decades with nanotechnology. But the point being, this is the process technology lets you put more and more transistors, more and more functionality on a given chip, for a given chip size. But at the end of the day, whether you make a 100 million transistor chip like our Opteron today, our 8th generation server product, or a billion transistor chip a few years down the road, or ultimately a trillion transistor chip, what does the chip do? And that's what counts. And that depends on the design. And so to me today, the most important thing is design. You have to have the process technology, but you have to have the design. It's all about content. And I think from the beginning, AMD focused on that aspect. And that's why I think today we're able to offer in our 8th generation hammer a product that outperforms Intel's Itanium, Intel's Xeon, Intel's P4, or Intel's forthcoming Banias. I mean, this is an incredible achievement in design and creativity. We get more performance out of fewer transistors because we have more innovative design. The future is all about design. It's all about content. And that's the only way you can win is to out-innovate the competition, and that's what we're trying to do. Excuse me.
Speaking about winning against Intel, is Intel a monopoly?
Well, you know, it's kind of interesting to me. When Intel has 100% of the x86 server business, which is what they had a year ago, and when they claim that 80% of all servers are now using Intel x86 processors, it certainly sounds like a monopoly to me. Now, unlike Microsoft, that had some fairly politically influential competitors who persuaded some politically powerful senators to encourage an aggressive Justice Department to go after them. No one has been able to do that against Intel. I mean, it turns out Intel has basically got all their competitors out of business except us. In the 80s, there were 15 licensees for x86 technology. Today, the only remaining competitor is AMD. So, yeah, I think Intel's a monopoly in servers, and that monopoly in servers gives them the ability to basically, from that safe vantage point, to subsidize other activities. You know, if you look at Intel's most recent results, Intel this year, 2002, you know, will have a profit, a lot less profit they had in 1998, but their sales will be the same. So they haven't really grown in 5 years. AMD will actually be larger in 2002 than we were in 1998, and we sold off 2 product lines. Yet Intel talks about how they're gaining market share. Well, the numbers don't work. They're not gaining market share. we're eroding slowly the monopoly, but Intel certainly is in a very, very strong position. And the way I see it, we would never be able to compete with Intel if we weren't more innovative. And again, it's people first and products and profits will follow. Intel has hundreds of engineers on a project. We have less than 100. So we just have to be better. But yeah, I think Intel's a monopoly. They certainly get monopoly rents. If you look at their income statement again, even in this terrible market, they've got a 26% operating profit margin in microprocessors, and they lose money everywhere else. They don't make money anywhere except in microprocessors, whereas I say, they brag on the fact that they've got 80 to 83% of the market. So.
But don't they need AMD so that they're less obviously a monopoly?
Well, there's nothing wrong with being a monopoly. It's not illegal to be a monopoly. If you got to be a monopoly by fair means, and the Justice Department decided that Microsoft was a monopoly, but they didn't say they got there by unfair means, but once you're a monopoly, you have to behave in a certain way. I don't think that Intel needs us. I think the customers need us. I think the consumer needs us. Intel doesn't need us. Intel would be much more successful if we weren't there. But then the industry would be dealing with some pretty second-rate technology and some pretty high-cost technology if all the systems were built on RAM bus memories, which Intel said they were going to exclusively use. Intel didn't want to use double data rate memories. I mean, it turns out, as brilliant as Intel's engineers may be, and certainly there are many brilliant engineers there, the realities are the rest of the industry has some innovation to contribute as well, and more so. And so I think we're much better served in a more balanced industry where all of the companies' innovations get brought to fore. In fact, that's what we want, is free and open competition so innovation can thrive. So I think, that, you look at, I don't know who'll be looking at this thing near term, longer term, but I just make an observation. When the semiconductor industry got started, the transistor was obviously invented in 1948, integrated circuit in 58, incredible, expansion and growth in the last 25 years, compound annual growth rate to $200 billion, by the year 2000, it's, even including 2001, which is a big down year, the historical growth rate for the last 25 years is almost 14% compound. So this has been a phenomenal run. It used to be fairly collegial at the start. People used to help each other. Then it became kind of a global battle. But now we got pretty much free trade and open markets largely, and we got to maintain that, especially with China becoming a more important market and a more important competitor. But I think that going forward, you said, what's the industry going to look like? Well, clearly, I hope that the industry starts to look like the automobile industry. That is, the most successful, most productive companies prevail, and there is a fairly balanced industry on a global basis. What I'm fearful of is the industry could turn into the aircraft industry. In the aircraft industry, basically, you've got one guy, Boeing, and you've got, Airbus, which is a competitor, a challenger, but it's been only made possible through the auspices of large government subsidies. So I think that it isn't good to have one company be so dominant. It wasn't good for the computing industry when IBM was that dominant company. The PC market certainly has become much more fragmented. The server market's more fragmented. But now you've got them all based on an exclusionary standard that Intel is trying to implement in Itanium, which would require everybody to rewrite all their software to go to 64-bit. So I think it's not respectful to the past. It's not free and open competition. It's not really true innovation. It's an exclusionary tactic to protect a business model, and I don't think that serves the greater good.
Well, we talk about monopolies under U.S. law, but in fact, Intel and Microsoft are world monopolies.
Yeah, that's true. I'd say the one thing about Microsoft, and we're supportive of Microsoft's position because they create a standard that everybody can supply to. The unfortunate thing is, if you're trying to supply a chip, in order for your chip to run under Microsoft's operating system, it has to have the x86 instruction set. And Intel owns the rights to that. That's in Intel's intellectual property, which we're licensed to. But that means that any other instruction set is severely disadvantaged. But anybody who wants to write application software, anybody who wants to build peripherals, to an x86 operating system that's driven by Windows has that opportunity. So I see a standard as being an important thing if it's an open standard, but unfortunately, Intel's standard tends to be a closed standard, and it would be more so if Itanium takes root. God, I'm having trouble here.
And of course, the reason that they came up with Pentium and Itanium and so on is the very reason you discussed. You can't copyright a number. So
Well,
the 8086 couldn't be copyrighted.
Well, that's certainly true, although, again, they did sue us. Excuse me. Maybe I should take one of your cough drops. Well, I think, talking about Fairchild, as I say, it was really a magic time. And Bob Noyce and a number of other people, certainly Gordon Moore, were just tremendously bright people that wanted to do wonderful things in technology. I don't know if it's widely known, but Gordon Moore was actually the one who created the concept of Intel. Gordon basically was frustrated with the inability of getting R&D developments into production at Fairchild, and decided he just wanted to go do something else. Bob Noyce at the time was a group vice president, and Tom Bay was the vice president general manager of Semiconductor. Charlie Spork had left by that time to go to National. And I think that Charlie's departure was really the beginning of the end for Fairchild, because when Charlie left, it signaled to all the guys in manufacturing that they were never going to get the support from corporate to do what needed to be done. The equipment, the investment dollars, as well as the reward. Whereas Charlie could offer them an opportunity with stock options, magic lure even back then, come over here and get a chance to build a corpus, build some wealth. So it's all about people, and when that stream of people started to leave, they'd already left. Some had formed, Signetics had been formed by Jay Last, Jean Hernay had left, another founder of Fairchild had left to form Intersil, and this exodus of people, which was natural at the time because a new industry was being created. But I think when Charlie left, and I love Tom Bay, he was really a great guy, but he really wasn't an adequate general manager. He made some terrible mistakes. And as a result, a new management was brought in. But the new management, as I say, when Hogan came in, they really destroyed the culture of Fairchild. I mean, Fairchild was, up until that time, we were a rowdy bunch, but we had a common goal, which was to build great products and bring them to market and beat everybody on the planet. And it was a very, very different mentality. So, when Fairchild then was under the auspices of Wilf Corrigan, who was a very, very smart guy, he'd already lost the momentum, to other companies. And I think it was inevitable that Fairchild would eventually just dry up, which is it's a sad thing. When you think about it, there's some poetic justice to the fact that Fairchild wound up being acquired by National Semiconductor, where Charlie had defected to, and that ultimately then National Semiconductor sold that off, and now the Fairchild name is back again, making basically simple, discrete products and simple things, as opposed to following this, what I consider to be the right strategy of building blocks of ever-increasing complexity. So it was a sad thing, I think. But you know what? There's a time and a place for everything. Just as I'm sure people could tell great stories about when the bean fields of Beverly Hills were being converted to mansions and movie studios, Fairchild had its place. But that era of the semiconductor industry was largely gone by the time AMD got started. 1969, it was kind of a new world. It was a much more professional world, and some of the roughhouse tactics maybe that Fairchild embraced just didn't have a place anymore. But it is interesting, that the people from Fairchild, myself, Bob Noyce, Gordon Moore, Charlie Spork, went on to lead, the three largest companies in semiconductors in the area. So there must have been something good. And I think what it really was, simply put, is what Schumpeter said. You know, Schumpeter, the Austrian economist, said, growth will occur when the entrepreneur is given the opportunity to innovate and the ability to participate in the fruits of his innovation. And that's what didn't happen at Fairchild. I mean, the innovators weren't properly rewarded. Syosset corporate was kind of taking it over, and just wasn't a good place to be. And I think that AMD and National were the antithesis of that. You know, it was give the opportunity for these guys to innovate and be rewarded for it. And I think Intel was too in the early days. Now Intel has become, you know, it's quite a large institution, but I think the concept is still there. But we'll see how it turns out. I don't think they have the same regard for their people that I have for mine. You know, I learned that there's an organization called FLAME, and it stands for Former Loyal AMD Employees. And I understand there's a similar organization, but they're all I Hate Intel employees. And they're all, so former Intel employees. So I thought, wow, that's kind of touching to think that you create an environment where people consider themselves part of a large family, and even when they're no longer with the company, they want to maintain that universe and that community. I'm very touched by that. And so, you know, here we are, you know, 33 years old, and, you know, we've still got a sense of family that I think is unique in our industry. But, you know, I think, you know, you get loyalty by being loyal. You know, we've actually been very loyal to the people. Just as an aside, we've never espoused Jack Welch's belief that you fire the bottom 5% every 12 months. That's never been our view. I think that it's much better to encourage people to compete, but as a team, and then the people just feel, you know, that they're really not able to participate, they kind of leave on their own. You know, I mean, it's the organism rejects them, if you will. And I think that's a better way.
So what is, in 2010, how many organizations will have wafer fab?
Well, you know, wafer fabs cost more and more to build all the time, and the cost per square inch of silicon keeps going up all the time. And in order to get a return, you have to amortize the cost of the development of the technology. So it's a very complex equation. Right now, if you look at, well, let's just take a quick look at history and where it might lead us. There used to be a time when the process technology was so unique, and I think that sort of ran out somewhere in the 80s, where people just had to have their own process technology. They developed a process to work with a certain design, and they built an integrated circuit. Then as people became more sophisticated, when you were pushing leading edge technology, there was always one company who was at the forefront of that technology, and they worked with the equipment manufacturers to spell out what equipment they needed to build whatever process they were building. And so for, you know, a long time, that was IBM. IBM was a technology leader, and so they worked with the equipment makers, and the equipment makers saluted IBM and made the process equipment that would satisfy what IBM's needs were. Then for a while, it became more Intel. And so Intel became the guy who was driving this. And I say, well, why could they do that? And the answer was because whoever had the biggest capital budget had the most influence on the equipment manufacturer. And clearly that was IBM for a long time. Then it became, you know, Intel for a long time. Now it's the foundries in Taiwan. So realistically, the Taiwan foundries are driving the equipment industry. And so they're building massive capacity. I think Taiwan is currently producing about 30% of the silicon in the world, which is an amazing thing for this small island. And they build foundries, and then people just use that standard process to build their designs on. Well, the only problem with that concept is whenever you have a standard, it means a standard process, you're not optimum. Now, for certain things, you want to be optimum. And there's two areas where you have to be optimum. One is memories, and one is microprocessors. And again, as I say in microprocessors, it's Microsoft stupid, which means it's got to be x86 instruction set. Well, that basically gets you to two companies, Intel and AMD. In memories, you've got, depending whether it's, DRAM, so then you got Samsung, Micron, and maybe a few others, but not many others. And in, flash, you got Intel and AMD and maybe Toshiba. Let's say Toshiba. But all of a sudden you say, wait a minute, that says that people building memories and microprocessors need optimum process technology. In my view, that says companies in that business have to have their own fabs. They have to have their own fabs so that they can implement that unique technology to enable them to get the optimum performance from their memory design or their x86 microprocessor design. That means that you have to have enormous market. Wow, that makes life very tough because you say, well, how many microprocessors can you build in one of these fabs? Well, I'll just give you an example. I think we can build 50 million microprocessors in our Dresden fab, and that's a single, 8-inch fab with 130 nanometer technology. Well, my God, we can build 50 million processors, and the whole PC market's only less than 150 million units. So we're saying, God, we can build 33% of that in one factory. And of course, if you go to 12-inch wafers, you go to 90 nanometer technology, and unless you follow a fool's errand of making ever bigger die, you don't need that many large fabs to produce a tremendous number of these things. Putting it another way, how many companies are big enough to invest $3 billion in a fab if they have to return several times those dollars to make it viable?
Well, what's the lifetime of this $3 billion factory?
Probably 5 years. Probably 5 years. So what that says is, if you don't have something to backfill that fab with, you have to have a very high margin on that business in order to endure. And that, of course, is the bad news about our industry. People say the semiconductor industry is made of a lot of smart guys who don't know how to make money. I think what it really is we've got a very interesting industry which is driving technology, the technology getting ever more expensive, and yet there are only a few opportunities to fill those fabs. So I think it's going to naturally evolve or devolve, if that's your point of view, to foundries and a couple of wholly owned or partially owned fabs by companies that need to have optimized technology. And that can be, certainly in Intel, certainly in AMD. But since AMD discovered years ago we couldn't afford to build multi-billion-dollar fabs when they cost $1 billion to build, we used our process technology expertise and innovation to leverage ourselves so that, for example, with our joint venture with Fujitsu, they provided the capital for our mega fabs in Aizu Wakamatsu. We provided the process technology. Our relationship with UMC, which is in its fledgling relationship today, we intend to use our knowledge on 130 nanometer and on bulk and SOI technology, going to 90 nanometer technology, going to 65 nanometer technology, to have a joint venture with them where we'll provide the technology and we'll get a benefit where we won't have to put up all the capital. So I think the wave of the future is alliances between companies that can develop leading edge process technology to have optimized solutions and companies that have access to low-cost capital. Well, who has access to low-cost capital? Subsidized industries. That was true in Japan in the 80s, true in Korea in the 90s, going to be true in Taiwan forever, as China is being part of Taiwan being part of the greater China. So I see that there's going to be subsidized capital available to any country's industry that has a chance of survival. And I say even a chance. I mean, obviously, there's a very large company in Europe which was built largely on subsidized capital, and that's ST Microelectronics. So what's the future? Well, I think the future is create the content that is fabless companies that create designs and ideas that will go into a standard process and will allow people to make a living and grow the business. But there's a flaw with that, because over time, as we put more and more functionality at ever lower cost on a chip, we can subsume the whole thing into one chip. So I mean, like right now, I mean, the Hammer family is an incredible chip, 100 million transistors. It's got an integrated memory controller. It's got all sorts of I/O ports, not to mention, you know, that it's got an incredible cache memory capability. So you say, wow, why couldn't we in the future put more on there? Well, let me tell you, the brilliance of Hammer is with these hyper-transport I/O capabilities, you can put 2 of them together, 4 of them together, 8 of them together, 16 of them together. Well, that's interesting for some very important, you know, scalable server. But what about if you just wanted to build a PC? You don't need that much power. But then you want to put 802.11 or some other, you know, wireless capability on there. So right now it's in the chipset. Right now it's on a card. Then it goes on the chipset. Then the chipset gets integrated with the processor. So over time it says if you have the process technology to do that, you can subsume all of this intellectual property in a single solution. And I think that that could make us look, as an industry, more like the aircraft industry than the automobile industry, where there's only maybe 2 or 3 companies 10 years down the road, or if not 10, 15 years down the road, that can basically integrate everything. And will those be the only successful companies, and the rest of us will all be relegated to some minor role? I don't know. I hope God gives me the continued good health so I can see that evolve. But I certainly do not see more than a half dozen companies probably owning their own fabs, wholly owning their own fabs. I see perhaps, if things go the way I hope they do, a dozen companies owning majority control of a fab in a joint venture situation. And the reason for the majority control is so that you can control the intellectual property. You need to control the intellectual property. So I'm concerned that companies with lots of intellectual property will bludgeon little companies. You know, for a long time, you know, AMD was referred to as a clone before we invented our own K5 and our K6, K62, K7, Athlon, now Hammer, Opteron. These are our own ideas, but we were called a clone, a copyist. I hated that, you know. The realities are we have paid less in patent infringement claims than Intel by a factor of 10. So if Intel is this great innovator, why do they pay hundreds of millions of dollars in patent infringement claims? And the answer is because they do whatever the hell they damn want, and then they negotiate from a position of power and throw some blood money at the guy whose patents they infringed. Meanwhile, they tie you up in courts forever. I was in court with Intel for 8 years on what was a contract dispute, which they tried to paint as intellectual property theft. And we won. We had the rights to all of this. But of course, by that time, all the soldiers were dead, right? You know, so we had to pick ourselves up off the floor and fight our way back. And we have done so, I think, magnificently, from a market share of less than 6% 5 years ago to 20% last year. And yet, 20% isn't enough. We got to get past 30 to get a more balanced industry, and I think we can do that. But to your point, or to the point, very few companies can afford a wafer fab of the 12-inch, 65 nanometer ilk. Forget about it. It's not going to happen. So that says you're going to have a Chinese partner or a Taiwanese partner or some other partner who's got lots of cash. Oh, no, maybe a Kuwaiti partner. You know, maybe somebody's got plenty of money who wants to provide the capital to create jobs, which is a non-economic reason. So I put this all together and I say, going forward, my successor, my hand-picked successor, Hector Ruiz, has the right model. Intel is the wrong model. Intel's spending $750, $800 million, $7.5 billion a year on capital, and they haven't grown their revenues in 5 years. What is the return on that incremental capital? It is so negative, it's destroying capital, really, truly destroying capital, because they're following an old model which says you will take all of your costs, accumulate them, and then add a price, add a profit to that, and that's what you sell it to the customer for. It's the old AT&T, Ma Bell. That doesn't work if there's competition. It only works if you're a monopoly and you add up all your cost and put a price tag on top of it. The realities are that can't work. You know, you can't sell mainframes anymore or big, powerful servers when guys can use blade servers or stack servers, get a lower cost solution as a result of semiconductor technology. So I believe that going forward, people will see that, hey, we're going to have to collaborate. However, what technology are you going to put in there? Because, you know, technology is invention. You know, and most of the process patents are held by AMD and Intel and IBM and maybe even TI now, of course, who are making substantial R&D investments. But the only way you can afford to make those R&D investments is if you can recoup them by large volume sales. And that means you're going to have partnerships, but that means that you have to control the process technology. Now, it turns out that's why I think there's only going to be a half a dozen companies. And with the grace of God and our continued, commitment to our people and their dedicated work, we'll be one of them. There's not going to be a lot of fabs of the 12-inch, 65 nanometer and below ilk in 2010. AMD is going to have one in 2007, 2005, 2007 probably peak in production. By 2010, maybe it's going to be 30 nanometers. It's going to be interesting. And when it goes below 30 nanometers, I'm getting scared because I don't know what to do below 30 nanometers. But they tell me nanotechnology is going to solve that for me. So we'll see.
Well, thanks, Jerry, for taking the time to tell us about life in Silicon Valley.
Okay, I'd like to just add one more thing if I could before you sign me out of here, and I'm delighted to get off the hook. But I was thinking about, the changes over the 40 years or so that I've been involved in this business. And as I say at the very beginning, it was all about process technology. Gee, if you could even make anything out of silicon that worked, you could sell it. To whereas then it went into manufacturing, and you had to make them cheap, and you had to make lots of them. Now I think we're getting to the point where process technology will continue to evolve, although within a narrower sphere of companies. Manufacturing will no longer be a distinguishing difference. There'll be a level playing field thanks to equipment makers and subsidized capital and the globalization of the world. So it's all going to come down to content. Who's going to have the great products? And so that says really, you got software and you got the silicon. And these guys have to work closely together so that the silicon can deliver the power of the software. It's all about content. And they have to really, really work close together because the box maker is just like a car assembler. That's not where the technology is. But delivering a solution to the customer, that's the future. And that's why, so you listen, now everybody's talking about, services. IBM's growth in the future is the service provider. EDS is their service provider. Where's the technology in that? That's just saying this technology is so complex, I'm going to help you use it. Well, that's okay, but that says you have to continue to have complex technology, and you have to make it easier for the guy to use. And to me, that's a combination of software and silicon. Put those two together, make them intuitive, make them, voice responsive. You won't have to have some guy showing you how to do it. You'll be able to do it because you've built it into the software and into the hardware. And I think that's what we can do with a billion transistor device, and if we continue to work collegially. So I think our future is bright in software. I think our future is bright in silicon, and it's whatever comes after silicon, but only if we work together and not exclude each other. If we do that, I think that we're going to have a great industry, and it's going to drive economic growth globally. And I'm looking forward to participating for as long as my life will let me. Thanks a lot.
Thank you.